Once I do that, I now have the relation between the two rates, right? The two ends of these equalities. dA dt is equal to 2 pi r, right? There's my proportionality, you might say, between this derivative and this derivative. Okay? Because the area is dependent upon r in some way, that means the derivative of the area, the rate the area is changing, is also dependent upon the way the radius is changing, the way r is changing. And so this is our related rates expression, one dependent upon the other. Now it's true you could view it the other way. You could view dr dt to be dependent upon dA dt. That's also true, right? But our view right now, because we're trying to find dA dt, then we're viewing it as A is related to r. Right? A is dependent upon r somehow. So the derivative of A is dependent upon the derivative of r. All right, so now I want to know dA dt, particularly when the radius is 25. All right? Now we'll start to fill in some pieces here. So dA dt, particularly when radius equals 25 centimeters. Okay, if that's the case, what does the right-hand side look like? Well, it's going to be 2 pi 25. But dr dt I have not filled in yet. But the question told us that the radius was increasing at a rate of 5 centimeters per second. So even though the radius is changing all the time, it's growing larger and larger, but the rate at which it changes is not changing, if that makes any sense, right? It's always a 5 centimeter per second rate of change. So therefore, dr dt is always 5. All right? So even though this derivative is changing with time, this derivative does not change with time. It's always 5. The radius changes with time. All right, so now we just crunch the numbers. What is this, 250 pi maybe, something like that. So 250 pi, and what are the units? Well, I could put all the units back in here, right? This was 5 centimeters per second. This was a 25 centimeter radius, and 2 and pi are just constants. And we could figure out what it is from there by combining the units in the proper way. But an easier way in general is to look back at the derivative you're talking about. This is 250 pi, which is dA dt. So the area of this circle, right, the numerator units would be, because we're measuring in centimeters, it would be centimeters squared. Right? The radius, the area of the circle. And time is measured in seconds according to the problem. That's the only time measurement we have floating around in there. So centimeters squared per second. And now we have, again, the rate at which the area of the circle is changing right when the radius, which is changing, right when the radius reaches 25 centimeters.